Class 10th quadratic equation and the topic is nature of roots. Students, before commencing our topic, let us see a video which focus on the need to study quadratic equation. So first of all, let us see the video. Students, whether you take the case of launching of any missile or any rocket, or you take the case of where we have to find the shape or speed of any celestial body, or if you have to find the speed of any moving object like cars you can see here or objects you throw, or you have to find the area of any region. In all these real life situations or examples, we have to deal with the quadratic equation. So quadratic equation play a very important role in the real life situation. So there is a need to. Now let us see the learning outcomes. After the completion of this topic, students, you will be able to find out the discriminant of the given quadratic equation. You will be able to deduce the nature of roots of a given quadratic equation, that is whether it has real and distinct roots or real and equal roots or no real roots. You will also be able to find out the real roots of a given quadratic equation if they exist. You can apply the knowledge of nature of roots of quadratic equations to solve the real life problems. Now let us see the previous knowledge. Students, at this point you are already familiar with quadratic equation. So let us revise it. When a quadratic polynomial is equated to 0, it forms a quadratic equation. Suppose I have a polynomial y is equal to ax square plus bx plus c. When this polynomial is equated to 0, what we get? We get ax square plus bx plus c equals to 0, which is a quadratic equation, and here condition is a must not be equal to 0, because if a equals to 0 we will be left with bx plus c equals to 0, which is a linear equation, and we are dealing here with the quadratic equation, so a must not be equal to 0. Example, 5x square minus 3x plus 3 equals to 0. You also know how to solve the quadratic equation, that is by using factorization method, completing the square method and quadratic formula method. So you are familiar with these three methods to find out the roots of equation. Standard form of the quadratic equation is ax square plus bx plus c equals to 0, where a not equals to 0. Quadratic formula is x is equals to minus b plus minus under root b square minus 4ac upon 2a. Now let us see the roots. A real number alpha is called a root of quadratic equation ax square plus bx plus c equals to 0 if a alpha square plus b alpha plus c equals to 0. That is, when alpha satisfies the equation, then only it is said the root of the equation. Now roots of quadratic equation. Since the equation is quadratic, it will have two roots. One of the root be alpha and the other root be beta. So now when we take the quadratic formula in this, when we take plus sign we get the value of alpha, and when we take minus sign we take the value of beta. So let us see, alpha is equals to minus b plus under root b square minus 4ac upon 2a, and the beta is equals to minus b minus under root b square minus 4ac upon 2a. So these are the two roots of the quadratic equation. Students, we have seen the roots, we have seen equation. Now what about the nature of those roots? So this is the topic of today, that is nature of roots. So first of all we will deal with discriminant. The expression b square minus 4ac in the quadratic formula, this is what b square minus 4ac. This is known as the discriminant of the equation ax square plus bx plus c equals to 0. So the expression b square minus 4ac is known as the discriminant. Now it is called discriminant as the word indicates. Discriminate means it can discriminate between the possible type of roots. It is denoted by capital letter D or del. We call this as del. So D is equals to b square minus 4ac. Thus when we write d instead of b square minus 4ac in the quadratic formula, we get the formula as x is equals to minus b plus minus under root d upon 2a. Now let us see how to find out the discriminant. So for that, example number 1 we have x square minus 2x minus 15 equals to 0. Students, whenever you encounter an equation, first and foremost thing is what? You have to make the equation or write the equation in the standard form. Standard form is what? Ax square plus bx plus c equals to 0. So what? Already our equation is in the standard form. So our first step is completed here. Now we have to find d equals to b square minus 4ac. So for this we need the value of b, a and c. So let us compare the equation and find the value of a, b, c. A value is what? 1. Value of b is what here? Minus 2. And value of c is what? Minus 15. So substitute the value of a, b, c to d square. D is equals to b square minus 4ac. So what is that? Yes, we get the same values. Now substituting the values to b square minus 4ac. Let us see what we will get. We have d is equals to b square minus 4ac minus 2 whole square minus 4 into 1 into minus 15. Yes, so calculate what is the value of d. Let us see. It is d is equals to 64. So this is how to find the discriminant. Now let us see why the discriminant is so important. It is important because it tells us the type or the number of roots we are getting. That is the nature of roots. Now discriminant can be positive, negative or 0. It means we can have d greater than 0, that is positive, or we can have d equal to 0, or we can have d less than 0 or negative. So these are the three possible cases for the value of discriminant. Now let us see some equations where you have to find the value of discriminant and see what effect it will have on the nature of root. So first we will compare the equation with the standard equation and find the value of a, b and c. So in this case you compare a equals to 1 we get, b equals to what? Minus 5 and c is equals to minus 14. So let's check the values now. Yes, we get a equal to 1, b is equals to minus 5 and c equals to minus 14. Now substitute these value of a, b, c to the formula of discriminant, that is b square minus 4ac. So find it out. Yes, what will be the value of d in this case now? Let us find it out. We get d is equals to 81. So what you notice here? Our value of d is what? Positive. That is we get here d greater than 0. So when d is greater than 0 or positive, what about the nature of roots? So for that let us first of all find out the roots and see the nature. So use the quadratic formula. We have x is equals to minus b plus minus under root d upon 2a. So first of all we will take the positive sign and find out the value of alpha. Put the values here, b, d, a. What we will get? 5 plus 9 upon 2, that is 14 upon 2. So value of alpha is what? 7. Now let us see the second case on taking the negative sign and find out the value of beta. So put the values again. We will get here 5 minus 9 upon 2, that is minus 4 upon 2. So what is the value of beta here? It is minus 2. So what you observe here? We get alpha equals to 7 and beta equals to minus 2. So are these numbers 7 and minus 2 real? Yes, they are real and moreover they are distinct. So whenever discriminant value is greater than 0 or positive, the nature of roots will be real and distinct. Now let's move further to the next case. Example 2 we have x square minus 10x plus 25 equals to 0. Again on comparing the equation with the standard equation, what will be the value of a, b and c? A equals to 1, b equals to minus 10 and c equals to 25. Let us check the values. Yes, we get here the values like this. Now what? Find the value of d. So substitute these value to b square minus 4ac and find the discriminant. We get here like this, 100 minus 100 what? What will be the value of d here? 0. So in this case we have discriminant equal to 0. Now when discriminant and 0, what is the nature of root? So let us find the roots for that. Again the quadratic formula we will use. Student, you see here when we write d equal to 0 here. So what will be left with? We will be left with minus b upon 2a. So either you take plus sign for finding alpha or minus sign for finding beta. In both the cases we will be left with x is equal to minus b upon 2a because this d becomes 0. So let us find first of all alpha on taking the plus sign. Alpha equals to minus b upon 2a on taking plus. So we get here alpha equals to 5. Now let us find beta value. Again beta will get minus b upon 2a. Put the values of b and a. And what the value of beta? 5. So what you see here? Alpha equals to 5 and beta equals to 5. So in this case value of alpha and beta are equal. So whenever discriminant is equals to 0, the nature of roots will be real and equal. Now let's move to third case. In this we have 4x square minus 9x plus 7 equals to 0. So let us compare the equation with the standard one and find the value of a, b and c. What's the value of a? 4. Value of b? 9 minus 9 and value of c 7. So find out the value of d here now. What will be that? 9 minus 9 is square minus 4 into 7. So find it out fast. Yes, d equals to minus 31. So what you notice here? Here we have d value negative. That is, in this case we have d is less than 0. So what about the nature of roots? Let us find that by using the quadratic formula. Again the formula we have, put the values of b, d and we get here x is equals to 9 plus minus under root minus 31 upon 8. Now you see this term, how to find the square root of any negative real number. So what to do for this? Can you find such real number, a square root of any negative real number? Or we can say, can you find a number whose square is minus 31? Can you think over this? No, we cannot find any real number whose square is minus 31. Let us take one more example. Here the smaller number I am taking. Suppose we have d equals to minus 4. So in this case, as minus 4 is less than 0, when we put this value of d in quadratic formula, we have to find the value of under root minus 4. But there is no real number whose square is minus 4. Or we can say like this, suppose we have 2 square equal to 4. So we can write 2 square equal to 4. Now, we can find a number whose square is 4. And what is that number? 2. Suppose it is given, we have to find a number whose square is minus 4. Can you find such number, that is x, whose square is minus 4? Can you find a number? Think over it. Can you find a number whose square is minus 4? No, we cannot find. So this is not possible here. So what we see now, whenever d is less than 0 or b square minus 4ac is negative, what will happen? Then there is no real number whose square is b square minus 4ac. Therefore, there are no real roots for the given equation in this case. That is, we cannot find any real number whose square is minus 31. So whenever d is less than 0 or negative, what will happen with the nature of roots? Nature of roots will be, that is, no real root exists. In this case, we will not be able to find any real root. Now let us summarize the three cases which we have seen just now. That is, when d is greater than 0, we will find two distinct real roots. One given by minus b plus under root d upon 2a. Other given by minus b minus under root d upon 2a. Next, when d equals to 0, we will have two equal roots, each given by minus b upon 2a. And when d is less than 0, in this case, we will find no real. Now let us see some examples here. First is 2x square minus 3x plus 5 equals to 0. Here you have to find the nature of root. So let us see how to find. Compare the equation with the standard equation, that is ax square plus bx plus c equals to 0. So on comparing, we get a equals to 2 and b equals to minus 3 and c equals to 5. Now put the values to d is equal to b square minus 4ac, as we have to find the nature of roots. So what is that? D equal to b square minus 4ac. Put the values of a, b, c. We get minus 3 whole square minus 4 2 into 5. You will get 9 minus 40. So here what you getting? Minus 31. So value of d is what? Less than 0. So in this case, now let us see the next question. Find the nature of roots. We have x square minus 5x plus 6 equals to 0. So compare the equation with the standard equation and find out the value of a, b and c. A value is 1, b value is minus 5 and c value is 6. So for finding the nature, we have to find the value of d, that is b square minus 4ac. Here I have used del instead of d. So substitute the value of b, a and c. You will get minus 5 whole square minus 4 into 1 into 6. That is 25 minus 24. So value of del in this case is 1. Since our del or d is greater than 0, real root exists and we will find two distinct real roots. So let us find out those roots now. In this case, real root exists. Therefore, we will write by the quadratic formula x is equal to minus b plus minus under root b square minus 4ac upon 2a. So we will write the value of b, a and c, that is minus 5, and this we can write the value of d directly here, that is under root 1. So we'll get here what? 5 plus minus 1 upon 2. Once we will take plus sign, so we get 5 plus 1 upon 2. Another minus sign, 5 minus 1 upon 2. So solve it, 6 upon 2 we will have and 4 upon 2. So whenever d is greater than 0 or positives, we will have two distinct real root. Here is 6 upon 2, that is 3, and 4 upon 2. Now let us see, find the value of k for each of the following quadratic equations so that they have two equal roots. So what is the first part here? 2x square plus kx plus 3 equals to 0. In this case, first of all, it is given that they have two equal roots. So in this case, we have d equal to 0. For that, we have to find out the value of d. So on comparing the given equation with the standard equation, first of all, we will find the value of a, b and c. So what's the value of a here? 2. Value of b is what? K, and value of c is what? 3. So now substitute these values to d is equal to b square minus 4ac. So values we have here, but since they have equal roots, so we have d equal to 0. So find first of all d. D is what? B square minus 4ac. So let's substitute the values of a, b, c in this and let us see what we will get. We will get here k square minus 4 into 2 into 3. So d is equals to what? K square minus 24. Now since d equals to 0, so we will have k square minus 24 equals to 0. We can write it as k square is equals to 24. So we have to find out the square root of this. So 24 can be written as 4 into 6. So 4 square root is what? 2, and 6 we can write root 6. So we get k is equal to plus minus 2 root 6. So this is the required value of k for which the equation have two equal roots. Now let us see the second part. We have kx into x minus 2 plus 6 equals to 0. Student, you see there in this equation it is not in the form of the standard equation. So first of all we have to write it in the form of a standard equation. For that we have to multiply these two terms. So multiply and see what you will get. Kx square, kx into minus 2 2kx plus 6. Now the equation is in the standard form and we will compare it with the standard form. So we will get the value of a, b and c. A value is what here? K. B value minus 2k and c value is 6. Now after comparing we have to find the value of d. But it is given that equal roots are there, so d value will be 0. So first of all let us find d. B square minus 4ac, put the values here. What we will get here? We will get 4k square minus 4k into 6. So it will be 4k square minus 24k. Now in this case we have d equal to 0. So we will write 4k square minus 24k equals to 0, which can be written as 4 we take common and cancel. So we will get k square minus 6k equals to 0. Now take k as common, you will get k into k minus 6 equal to 0. When we take k equal to 0 and once we will take k minus 6 equals to 0. So we will have two values of k. One is k equal to 0 and one k equal to 6. Now student, you see in quadratic equation we know the condition that the coefficient of x square must not be equal to 0. That is a must not be equal to 0. So in this equation you see we have kx square minus 2kx plus 6 equal to 0. So here we cannot have k equal to 0. But here k equal to 0 is coming, so we have to discard this value of k and so we have to write only k equal to 6. Discarding k equal to 0, we get the answer k equal to 6 is the only value of k for which we have the equal roots. Now let us recapitulate what we have learned today. We have learned if d is greater than 0, we will have two distinctly real roots and one root given by minus b plus under root d upon 2a and the other is given by x equal to minus b minus under root d upon 2a. We have seen if d equal to 0, then we will have two equal roots each given by minus b upon 2a. And if we have d less than 0, we will have no real roots exist in this case. Now let us see some home assignment. In this, determine the nature of roots of following quadratic equation. So equations are given, you have to find discriminant and see whether d is less than, greater than or equal to 0, and on the basis of that you have to find the nature of roots of the equations. Next, question number 2. Here what is given? Is it possible to design a rectangular park of perimeter 40 meter and area 200 square meter? If so, find its length and breadth. Let us see the hint. It is given here first of all using the given information. What information is given? Perimeter and area. So using this two information, find out first of all the quadratic equation. Then apply the concept of nature of roots to find whether the solution exists. If real solution exists, you can find length